Hello everyone. So in this video we are going to solve a question of LeetCode, that is mirror reflection. So let's start with the problem statement. There is a special square room with mirrors on each of the four walls except for the southwest corner. There are receptors on each of the remaining corners numbered from 0, 1 and 2. So we have basically given three receptors, that is 0, 1 and 2, and we don't have any receptors on this bottom left corner, right? And the square rooms has walls of length p, so we have basically given two values p and q, and each wall is of size p, and a laser beam from the southwest corner first meets the east wall at a distance q from the zeroth receptor. So this q is a distance from the bottom, or we can say from the zeroth receptor, right? So, and what we need to do is, given two integers, return the number of the receptor that the ray must first meet, right? So basically we need to return the number of the receptor, right? The number of the receptor, whether it be 0, 1 or 2, right? So we have three possibilities, 1, 2 and 0. So in any of the three possibilities we need to find out some combinations, right? So let's quickly see what are those combinations. This question seems to be difficult, but it's a very easy question, I would say. Let's quickly see how can we approach this question. So let's say we have given a square. So let me draw a square here. So let's say we have given a square, and in that square we have 0 here, right? Then we have 1 here, and we have 2 here, right? And we need to start from this point, right? We need to start from this point. So let's see what are the possibilities for p and q, right? This is p, let's say, and this is q, right? And we need to find out the three combinations for the outcome of 0, 1 and 2, right? So we need to basically reprint 0, 1 and 2 as our answer. So let's see what are the possibilities for this, right? So let's say this ray, let's say this is first p, right? This distance is p, this is p. Now let's say if the ray meets the east wall on the middle, right? Let's say q is here, and q is basically p by 2, right? This is p by 2, or we can say this is a center of the wall, right? So in that case, let's say this is p by 2, right? So in this case, this ray will go from here to q, right? This will go from here to q, right? And from q to 2, right? So in this case we are getting 2 as our answer, right? So what are the possible um, values for p and q, right? So in this case, let's say p is 2, then q would be 1, right? Let's say p is 2, and then this is q is the half of the p, so let's say q is 1. So in this case, when p is 2 and q is 1, so we will get 2 as our answer, right? So we have got our first possibility for 2, right? Now let's see the possibility for 1 and 0, right? So what is the possibility for 1? Let's quickly see. It's very straightforward. We are just directly going from this point to this point, right? From this origin to 1. So what is the possible values for this? Let's say this is p, and this q will also be equal to p, right? Because it is taking the whole wall from here, right? So let's say q is here, which is equal to p, right? So let's take the value 1 and 1 for both of these, right? We are basically finding out the minimum value in this possible case, right? So the minimum value for p and q for this case is 1 and 1, right? Similarly, for the previous case, the minimum value for this would be 2 and 1, right? Now let's see for the third case. In this case we were getting 1, right? We were getting 1. Now let's see for the third case. The case is for 0, right? Now this is a very important case because we need to also make a reflected image for this, right? So what could be the possible answer for this? Let's say this ray go to 2 by third distance from here, right? So let's say this ray meets here somewhere, right? and from here this array will go beyond this. So let's make one more square here, right? So let's say we have one more square here, something like this, and this square is reflected here, so 0 will be here, right? Now this ray will again reflect from here to here, right? and from here to 0, right? So what is the distance here? This is basically 2 by third of p, right? This is 2 by third of p. So what could be the possible value for this, right? What could be the possible value for this, or we can say the minimum value for this? So the minimum value for p would be, let's say we take p as 3, right? So for this p as 3, and if p is 3, then we will get q is equal to 2. So this q is equal to 2, so in this case we are getting 0, right? So we just found out the possible combination for 0, 1 and 2, and this only we need to code, right? This is the only thing we need to find out in this question. Now I hope these three possible combinations are clear to you, and let's quickly move to the coding part. We just need to check these three conditions in the if conditions, right? We will just write three statements for if condition by checking these values, and we will get our answer. Like we will return 2 for this, we will return 1 for this, and we will return 0 for this, right? This only we need to do here. And to find out the minimum value, right? To find out the minimum value, let's say we have given p is equal to 10, right? And we have given q is equal to, let's say we have given q is equal to somewhat 4, right? So in this case what can we say is, let's say we divide p by 2 and q by also 2, right? So in this case we will get 5 and 4 is 2, right? So what can we conclude from here is that this p is 5 and q is 2. So these are the minimum possible value we are getting, right? The minimum possible value of p and q. Now if we compare this value with our possible combination, so what can we say is p is odd, right? This is odd and this is even, right? So what is the combination here of odd and even? So we can clearly see this is odd and this is even, so we will get 0 in this case, right? Only this thing we need to do in this question, right? So let's quickly code it up. I hope the approach is clear to you. So what we were doing, we were first dividing the values by 2 to find out the minimum possible value of p and q, right? So let's quickly see. While p is divisible by 2 and q is divisible by 2, right? So we will just divide both the values to find out the minimum possible value. So p divided equal to 2 and q divide equal to 2, right? Now let's check all the three conditions here, right? So what are these three conditions? Let's quickly write. If p2 is equal to 1, it means p is odd, right? And q modulus of 2 is equal to 1, it means p and q both are odd, right? So what is a possible case for this 1 and 1 both are odd, so we will returning 1 here, right? Let's return 1 from here, return 1, right? Now let's write the second condition. If p modulus 2 is equal to 0, right? If p is even and q is odd, right? In this case, let's see. If p is even, that is 2, and q is odd, that is 1, so what we are getting? We are getting 2 as our answer. Let's return 2 from here, return 2, right? Now the remaining case would be 0, so let's directly return 0 from here, return 0. I hope this is clear to you. This is a very simple approach to solve this question, and let's quickly try to run this on the sample test cases. Yeah, it's working fine. Let's submit this. Yeah, it's perfectly fine. So the time complexity for this solution would be big O of log of p. This is log of p because p is the maximum out of p and q, and we are just dividing it by 2. So this while loop will run at max log of p times, and the space complexity is constant. Alright, so that is it for this video. I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.